Hello. You know what you should do when you start a live stream on like a thing like YouTube? You should turn on a microphone so that people can hear you. What do you think? Do you think I can just turn off the stream, wait a couple minutes and turn it back on and then delete that whole thing from the internet? I guess I'll just keep going. Now you should be hearing me okay. Let's start over again. Let's just pretend I will fix my hair. And I'm looking at the wrong chat here. I got all the chats going. Okay. Okay, let's try this again. Ready? Take 2 for the coding train. Hello. Good evening. Do you hear that static? The train was very delayed. There were lots of problems. This is not a European train that's efficient and on time, or what I imagine it would be. It's a New York City Schiffman train that was very, very late. It's been a very long and very, very busy day. I am remarkably unprepared to be doing this live stream right now. Now you might be saying to yourself watching, aren't you always unprepared? You're never prepared. This is true. But I usually go through some amount of preparation ritual, like when I'm riding the elevator up to the floor where this room is, I might think to myself about what I'm gonna do. Or I might, just take a moment to breathe and relax. But no, I had nothing. I just kind of ran in here, moved all the cables around, turned it on, and here we go. All right. I feel like I really need that music. Now, do you hear a little bit of I should admit something. Usually, I have a nice ginger tea. That's what I like to order on the coding train. Sometimes, you might even find me with a green tea. Perhaps a green tea with a dash of some other sort of fruit flavoring. I don't know, maybe that's bad. Maybe we shouldn't have green tea with any flavor. But anyway, this is coffee. It's 6 o'clock, which is a terrible idea. It's a very small, weak, barely, mostly it's almond milk, frankly, but there's a little bit of coffee in there. That's really what you tuned in to hear about. What I would like to do is everyone's falling asleep. My AirPlay technology, which gives you the soothing lullaby sounds, doesn't seem to be working very well. Let's try this.
As always, I always forget the this dot, this dot, this dot.
Do you hear that? It's like skipping.
This dot, I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot's on. This dot, this dot.
Getting messages here. I will turn those off. Okay, it's working fine. All right. Welcome to the Coding Train, a weekly live stream on the YouTubes where I, Daniel Schiefman, I'm still working on the pronunciation of my last name, it's very tricky, come to the channel to make lots of mistakes, program in terribly inefficient ways, and hear all of your corrections and comments. Before I begin, I would like to continue with our story, A Million Random Digits. I believe I was on page 3. I'm going to get to page 3 eventually. 2. There's like a really loud thing going on in the hallway. Can you hear that? There's like a party or something. It's very distracting. Okay. I'm now going to turn to page 4. 94,015, 46,874, 32,444, uh-oh, this is a really good part, 48,277, 59,820, 96,163, 64,654, 25,843. 41,145. 42,820. All right. You'll have to wait until next week, where I will continue the random numbers. How many viewers have I lost? I don't know. I can't. I have this. They used to have this thing where I could see how many people were watching, and I like to watch all the numbers go down as I read the random numbers. But I can't seem to. I don't have that on one of my screens right now. Okay. Programming, tutorials, discussion, that sort of thing. Is that what we're here for? Let's give it a try. I'm going to charge these batteries and put them in my battery charger. I'm over here. You can't see me, but I'm at a battery charger. Click, click. Whoop! Ah! I tripped over a wire, but everything's okay. I'm over here. And I just want to put these batteries in the charger in case the microphone batteries die. I have some ones I can charge up. Now, I need to do some sound level stuff with you guys. Can you bear with me for a second? I am going to play the This Dot song. Oh. Uh-oh. Something happened. My sound system disappeared. Let me try this again. Sorry, everybody. This I know is super exciting for you to see. Okay.
As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot.
It's gonna get louder.
This dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot.
Is this a good volume of the song for you to be able to hear it, enjoy it, and yet I can kind of speak? Okay. Now, how about this? I felt that when I watched one of my videos back, this new timpani sound that I'm really excited about. Oh, the camera went off. You couldn't hear. But the music was too loud. So I've lowered the music, but increased the timpani sound. What about this sound? Good? 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 It's a very long drum roll. I gotta get a shorter drum roll sound. Look. Okay. Now what about the kitten song?
Unicorns and rainbows and
There.
cupcakes. What else is there? Yes, kittens. Thank you very much.
Thank you. Yes,
And
kittens.
rainbows and cupcakes. Notice
Oh.
that. Look what I get. I really lose my mind. Okay, let's do it.
Okay. I did make some notes. Kitten song. I did make some notes. Oops, I've lost my chat here. Okay. Okay. Okay, so I did make some notes at some point, which are things that I'm thinking about doing today. So let me go over these and we can see. So I want to talk physics engines. And I think actually I really should just scratch everything off this list and just focus on doing a few examples and tutorials about a physics engine that's a JavaScript library called matter.js. So that's something I'm thinking about. I do need to continue my discussion of prototypal inheritance. Prototypical, I don't think that's how you say it, but I like to say it that way. So I need to continue that. I would like to do that processing in Eclipse series. I need to get started with that. And of course, I must get to the Chrome extensions. Very, very important. We'll be pulling into the Chrome extensions station very, very soon. Yikes. That's a horrible sound. Okay, and I got to work on this. I'm out of practice. Okay, let's see. Challenges. Oh, I keep getting people sending this to me. This thing called the Bonus equation, which is just a little like kind of spirograph algorithm that you can trace out and make these like beautiful fractal patterns. I thought this would be fun to try to make and see what patterns we could get. Pretty flower, beautiful pattern thingies. So that's something. That's something that I'm thinking about. Ripple effect, this 2D water ripple effect, that's been requested, so I've been thinking about that. Why is this not scrolling? Okay. Okay. So let's see. So now I'm looking at the Slack chat. Oh, so some people posted some things. If I go to here, can I see that? I don't know how to do this. I'm not sure, Robin, where that's posted. Boy, I'm like losing it here. I forgot that I was on the internet and a live stream. Okay, let's just get moving here. So what I like to do often is show work from the community. And this is where I press my bumper music for work from the community. Time for work from the community. Yeah. Okay, today, submitted from the community is, it was not submitted, but I have a Slack channel for patrons of my YouTube channel here, and Mr. Musad Icht posted something which I thought was really interesting to think about. So, which is visualizing the newly discovered TRAPPIST-1 solar system. So, if you have been following the news as of late, NASA made a discovery of 7 exoplanets that I believe it will only take 40 years traveling at the speed of light to reach, traveling around a star in a nearby solar system, nearby being 40 light years away. And there's a lot of information and data and stuff that was recently released. So I would love to do a challenge about looking at this data and maybe visualizing some stuff with it. And this is a Reddit post. Now, for some reason, I thought I saw some images here, but let's look at this paste bin code. And I'm going to grab it and see if we can look at it in processing. Let's launch processing. Now, so many people suggested to me this like fancy technology where if I had a link posted over here, I could make that link go to this computer. And I forgot to look into that because I'm woefully unprepared. But let's try this and see what we get. There's so much noise outside of the door. Here, let's see if you guys can hear this. Hold on. I'm tripping over wires. Unplug this wire. Hold on. I'm trapped. I'm trapped. Hold on. You've got to hear this because I want you to know that I'm not a crazy person. I need a roaming camera. Where's my roaming camera? Okay, I'm coming over here. I'm opening this door. This, my friends, is the outside world. I am in a room by myself, no windows. I see a window, it's dark outside. Through this door is glorious other people. New York City, so many places. I will walk, you can hear. I have returned. You probably can't really hear that, but it's very loud. It's really distracting me. Okay, I'm back. Thank you for this project. I'm going to go back to the Reddit page and see. Okay, I've only worked in Zoom functionality, but I've created Sol and its solar system overlaid. Whoops. I'm going to read this. Overlaid with TRAPPIST-1. You can find the code here. Color of orbits indicates habitable zones. Each planet has individual colors as well. That's great. I don't know if you're. Oh, yes. Mr. Moose is in the chat. What I would like to know is where did you get the data from? So I would love to see that data, and maybe we can do a challenge about it. And I will, when this video gets archived, I will post this link into the chat. So apologies to everyone who is sharing things with me through the Slack channel. I've sort of failed to properly get things ready and have some of these links available. So I think what I'll try to do is next week do an extra long work from the community a segment, and I'll come back to it later. I like people's online handles. I like to just butcher the pronunciation. So, yes, I am also addicted to mooses. What's the plural of moose? Mooses? I see a lot of mooses. Okay. All right. So that's good. So here's what we've got. I think I'm going to need to use my randomizer, because I know of no other way of picking what to do. Matter.js, yes, that's an option. Continuing my discussion, of prototype inheritance, that is an option. Fractal Spirograph, why not, right? I keep on, Benice, anybody know how to pronounce that? The plural of moose is just moose. That, my friends, the more you know. Where do I have my more you know sound effect? The more you know. That doesn't really work. No, it's too hyper. Okay. All right. So I think I'm going to leave these three as things I'm going to spin. Oh, I had a really good pull request with another way to pick, but I didn't do it like. Whoa. Okay. I've had some nice pull requests on this wheel spinning thing to help me with sort of design and features and that sort of thing. Would love more. Anybody wants to help build this ridiculous spinning wheel thing? Make a Plinko system? I don't know. There's lots of possibilities. Okay. How long have we been in this? Oh, I'm only at 18 minutes. This is great. If I get started coding something before 30 minutes. Oh, Alka tweeted links to the coding train. Great. I'm going to take a look at that in a second. Let's actually do that right now. So Alka has some things to share from the patron group. And I'm going to go to my notifications here, which clearly I haven't checked. And let's look at Alka's project here. CodePen. So this is Alka's variation now of the matrix range. So hopefully you guys enjoyed that I was able to publish a guest tutorial from Emily Shia. If you haven't seen it, I highly recommend you watch her guest tutorial. Created a matrix rain effect. And looks like here is Alka's variation on it. Two things there. Okay, only one showed up as the preview. And let's try this now. This is called Flick Physics. Oh, so this is perfect to look at. Hold on, let's go to full page. So this is great. Looks like I get to just sort of flick around and move these things with physics, which I love. So one question I'm wondering about, so this is perfect, thank you Alka. So one of the things I really want to discuss today is why would you want to use a physics engine? When would you not want to use a physics engine? When would you want to use a physics engine? How do you pick a physics engine? What do physics engines do? What kind of features do they have? So I would like to discuss that as a kind of general topic. So, And I'm looking in the chat to see maybe Alka is going to send me a message about how this works. Can really hear the people outside now. Yeah. Look at the Google document chat, please, says Peppa in the YouTube chat. I'm afraid to do that. Okay. Steering paths and polygons. Great. I'm going to take a look at this. Oh, look at that. This is fantastic. You guys never disappoint me. I'm always afraid when there's some like public chat thing that I'm going to pull up that the trolls are going to win. But today, there is nothing but glorious computational art makers. So look at this. So this looks like a wonderful variation on my steering behaviors and font paths. But rather than actually just trace the outlines of characters with dots, what this project is, which is made by Josef Kuchar, is actually building the letters out of triangles, geometry. So the letters are put together almost like puzzle pieces that then separate as the mouse goes near them, and then they come back and put together. I love this variation. I would love to see it colored. I think there's a lot of possibilities with like rainbow colors and different things here. It would be interesting to see, but there's a sort of beautiful simplicity to the grayscale values as well here. I'm curious what it would look like without the stroke outlines. I love seeing the triangulation and the geometry that's present here, but I wonder what it would be like to really feel like this is just text and then realize and see it breaking apart. And so some people in the chat are asking, how would you do something like this? And the way that you can create, you can see every single thing drawn here is a triangle. And so there are, with begin shape, end shape, and by passing an argument to begin shape by setting the kind of geometry you intend to draw, perhaps a triangle strip is a way that you can set a lot of points and have it sort of tiled triangles, is likely a way that this possibly was made. So thank you for this submission. It's really wonderful. I'm excited to be able to share it. So Alka writes about the trigger physics example that it uses p2.js and p5.js, and you can use the arrow keys in addition to the mouse. Okay, thank you for these wonderful submissions. I really enjoyed this. Work from the community. Okay. I need a better name and maybe some actual like melody there. It's loud, isn't it loud? I don't know about this. Maybe it'll end at some point. Okay. Okay, so now let's go back to let's try the arrow keys. Look at this. You can do the arrow keys. And so I'm just going to bring up p2.js. Is a 2D physics engine for JavaScript. Yet another one that I didn't even realize existed, so that's great to see. Okay, so hard with the noise. Okay, ready? So these are three things that I kind of didn't put the 2D water because I feel the topic of my course at NYU this week was physics engines, and I did a lot of stuff in class today about Box2D and toxic libs, but I already have a lot of videos on those, and I thought it would be worth exploring a native to JavaScript physics engine like matter.js. What time does the party end, I wonder? Okay, let's spin the wheel. The least relevant thing, I shouldn't have even allowed it on there. Do I get a do-over? No. I must do what the wheel tells me to do. The wheel tells me to program, I program. It's like the claw. I was watching Toy Story recently. I love those little aliens. Okay, why was I watching Toy Story recently, you might wonder? Another story for another time. Okay, here we go. So to be honest, I know nothing about this other than I keep getting this link sent to me. So first, let's see if we can find out why it's called Benice. I'm not sure how to pronounce that. Benice equation. What if I just Google that? Fun with math, art, images, fractal spirograph, fractal roulette, beneath education in Scratch. Does anybody know where it comes from? We don't know. Let's see, I guess. These are all interesting. Ooh, look at this little, a monster equation. Ooh, we should do these sometime. These look fun. Whoa, look at this. So many things. I'm looking for Benice. Posted by Benice. Oh, maybe this is Benice's blog. Maybe it's called Benice for a person who posted it on their blog. Pixar, I'm looking in the chat for somebody to, wow, it's really getting louder. Okay. All right, we're gonna, it's also getting very warm in here. Do I have the air on? Okay. You know what? I'm gonna rise to the occasion and I'm gonna come to this page and I got it and I'm going to leave this here. I'm gonna leave this here and I'm gonna close this. And we are going to do this in, I think we're going to do this in P5. I think it would be nice to have this on the web. I don't think it needs anything from processing in terms of speed or performance or 3D. So I think P5 will work for this one. So now, interestingly enough, Solar System 2D, Schiffman. Ah, look at that. Yeah. Okay, so this coding challenge, Solar System, is actually quite similar. Let's see if we can pull up the code for this. What did I do it in? I did this one in processing. So that's an argument for doing this in processing. But let's open up the code for this coding challenge. Let's see where I can find it. Do I keep these things on this computer? Solar System Generator. Let's try this. Oh, this was in 3D actually. So I must have moved this to 3D at some point. So this is an example that I did in a previous challenge where the idea is to have this sort of this level of nesting. So I draw spheres. Each sphere keeps track of an array of other spheres that rotate around it. And each of those keeps track of other spheres that rotate around it. And you can see this sort of like nested rotations, which is very similar to what you see going on in here, that there is a circle rotating around another circle with another one rotating around it. And there must be some logic to the speed at which they rotate. And then a path is traced. Here's the thing though, what I did with the previous example was to use translate and rotate in a nested fashion to sort of leave the rendering, leave the positioning to the transformations that a graphics environment like processing or P5 can do. But so some people are telling me to check Twitter, so maybe I'll do that in a second. There may be a link there for some more information about this equation. But I think what I would like to do here is do this using trigonometry. So I would like to calculate the rotation point with trigonometry of the circle, of each circle, and that way I can have that XY point that I can trace more precisely. Okay? And I believe if I look down onto this blog post, and this needs to be a little higher for me, that I will find an equation. I thought I saw that equation too, but these are just the pictures. Okay, let's look at my notifications here. Well, I don't see, ooh, this looks interesting. Nice little heart, thank you for this. It's also in Spanish. Okay, so I'm going to do this as a coding challenge now. I'm hoping it's going to happen rather quickly so I can move on to some of the other topics. I'm going to get my eraser and my marker. I really need to wash this whiteboard, and I really need to not leave it with the for like a week with whatever I last had on it. So that's going to be one of my activities that I really enjoy early next week, of coming into this room and just washing this whiteboard. And here we go. So I think this is one, I'm in the wrong camera. I think this is one that I hopefully don't need to, I need to fix this wire because I keep getting it caught on me. This is hopefully one that I don't need to do an extra intro for. And here we go. Coding train. Always remember to hydrate. Let's see. Okay. Let's see. Alka asks, is that top to bottom, ceiling to floor whiteboard paint? It is top to bottom, almost to the ceiling, to floor whiteboard paint. It doesn't go all the way up to the ceiling because the ceilings here are quite high, and it goes about as high as I can reach. Okay. Let's see here. And I will finally soon do a walkthrough. Next week, I am committing to doing a walkthrough of the studio and how everything works sometime next week. So I will try to do that next week. Okay. So let's do this in P5. Let's do this in processing. I don't know why. A lot of people have been requesting processing, and I sort of feel like let's just do that right now because I have it open and I did the solar system stuff in processing. So let's open this here and let's do Benitez equation. Okay, I'm going to add setup and I'm going to add draw. Make this a little bit higher. I'm going to add setup and draw. I am going to and say size 600, 600. Let's see how this looks. And have this pop up over here. And there we go. Okay. Well, everybody in the chat has a different opinion of which to use. Here's the thing. I am happy to commit to anything that can be done in both environments for whichever I happen to do it in the challenge, to porting that code to the other environment so that the code is available in both. Now, processing does have a function called screenX, which Robin in the chat points out, which is quite useful for me to use. But I still think that I want to do it without the transformations. Maybe we'll do it both ways. Okay. Fractal spirals. That's probably what we should call it. Orbital fractals, fractal spirals, spirals, nested circle spirals, Benitez, etc. Okay. Okay. Here we go, everybody. You ready for this? I'm going to clean my glasses. I'm going to have a moment of quiet contemplation. I will not be distracted by the noises in the hallway. I will drink my water and stay hydrated. I will make mistakes in my code. I will use inefficient algorithms, and I won't mind later or something. Okay. Okay, here we go. Ready? Coding challenge, take 1. How about I do one with no starting over and no stopping? Okay. Fractal Spirograph. Okay, here we go, everybody. Ready? Here we go. Hello. It's time for a coding challenge. Oh, crap. What's wrong with this AirPlay connection? Do you guys hear that? That it's all like, I don't know why I like this lullaby music so much. I should get some different lullaby music. But do you hear that crackling? It's not really working. It's driving me crazy. I want somebody to tell me that it's either fine on the stream or that you hear that as well. I've only got 1 tissue left for tonight. I've got plenty of water, but only 1 tissue. Yeah, it was crackling. Okay, thank you. Thank you, everybody, for telling me you hear it crackling. I will not use the lullaby music right now. Okay. Remember I said no stopping and starting? How did that go? Hello, welcome to a coding challenge. In this coding challenge, I am going to attempt to make something that is called a fractal spirograph, perhaps, or fractal roulette, or sort of like an orbital thing, or a pattern thing. That's, I think, the technical name, actually, is pattern thing. I'm getting an incoming call. I have to press don't answer on my don't answer. Okay, what was I doing? I'm on the YouTube's We're Making Doing Coding Challenge. So this was requested. It's in my Rainbow Topics repository, and I'm still trying to figure out why it's sometimes called the Benese equation, and also how to pronounce that. So perhaps it's called that because somebody who keeps a blog, maybe their name is Benese. And I really should just research this, but I'm going to rely on the YouTube audience here to correct me and fill me in the comments. So you can see here that there's this idea of nested circles orbiting each other, and then the smallest one, and sort of like the last nesting of the circle, tracing out a pattern, and you get this kind of nice, beautiful fractally thing. And so you can see here's a bunch of varieties of it. Oh, I really like this one. Maybe we can try to do this one. So I'm going to try to make one of these and see if we can get it to work. And you will hopefully then adjust the code, think of your own ways of making the pattern, of using color, your own design and creativity. I'm going to do this in processing. Now, processing, if you're not familiar with it, I'll try not to say this in every video I make, but it is a Java-based platform with a robust drawing library and a development environment. So I'm going to be able to just write code with Java syntax, call a lot of drawing functions, and see the results of my program in a quick sketching, prototyping way. Now, another thing I want to mention is this is quite similar, and let me come over to the whiteboard here. This is quite similar to a coding challenge I did a while back called Solar System. Yes, thank you. Thank you very much. Thank you. Did you hear that? Or am I just doing weird stuff? People started cheering in the hallway. I'm not sure why. Okay, so in the Solar System Coding Challenge, I created a system that had a circle. And each circle had some number of other circles orbiting around it. And those had other circles orbiting around it. And I used to do this functions like translate and rotate. And these function calls were nested. So I would, from the center of one circle, translate out and then rotate by some angle. And then I would translate out again and rotate by some angle. So that I could have nested circles orbiting each other, which is very similar to, and so the idea of this is like the sun, and this is a planet, and this is the moon, that sort of thing. This is quite similar to what you're seeing in this orbital fractal thingy. But I think what I want to attempt to do in this challenge, for no other reason than just to see a different way of doing it, is to actually use some trigonometry math. So if I know the radius of this circle, and I want to have another circle right outside of it, and I know its radius, then I can figure out where this circle should be positioned based on polar coordinates. And this is something that I've used again and again and again in various coding challenges, where I say, okay, I have a two-dimensional space with an x-y coordinate, and then I can also think of that x-y coordinate as a distance from the center r and an angle. So x equals radius times cosine of that angle, y equals radius times sine of that angle. And this is a formula for converting from a polar coordinate to a Cartesian coordinate that I've used again and again, and I will once again link in this video's description to a video that covers this formula in more detail. Okay, this is going to be a little edit point because this camera over here went off. And yes, it does kind of look like Pac-Man. Sorry. Or not sorry, because that's cool that it looks like, cool is the wrong word. It's whatever. Okay, here I'm coming back over here. So let's start trying to program this. Let's start in a very basic way. What do I need? I need a circle in the center. So I'm going to make a global variable, which might not be necessary, called r. But let's just make it global just to see later how we're going to use it. And let's make that radius 100. Let's start with a radius of 100. So I'm going to set a background color of 51, because that's my favorite background color. And I am going to then say no stroke. No. I'm going to say stroke of 255, no fill. So I want to have an outline of a circle with no interior. And then I'm going to use the ellipse function, which draws a circle at 300, 300 with r times 2 as the width and r times 2 as the height. And if I do this, I have my first circle. So some things that I might do just to make it easier for you to see on the live stream or however you're watching this is just increase the stroke weight a little bit so I have a little bit of a thicker circle. Now, I want to position a circle right outside of it, and maybe I want its radius to be half the size. So let's work out the math for this. So what I need to do is I also need an x and a y. So that's going to be the center of the first circle. And I think I'm going to need to do this in an object-oriented way soon enough. I really didn't plan this out at all. So this is going to be at x and y. So now I want another circle. I'm going to say, and let me not make these global variables. Actually, I'm just going to sort of figure out a static version of this just to get started. Then I'm going to say r equals r times 0.5. So r divides by 2. So I'm going to have I'm going to say R2 for the second circle. I'm definitely going to need to do some object-oriented way of nesting these, but I'm just doing it this way for right now, just to get the basic idea. So now what I need to do is say x2 equals x plus r2. And then I can say ellipse x2y r2 times 2 r2 times 2. And now we can see I have two circles. So I just wanted to see the basic idea there of putting two next to each other. Why does this work? Here's a circle at xy, and here is a circle at x2 comma y. This is r1 and this is r2. So you can see x2 is offset by x by r1 plus r2. Now, of course, things are going to change quite a bit once I start this to rotate. Let's see if we can just make just this rotate around. How do I do that? So really, the answer here is what I really need is an x2 and a y2. And really the distance is, oh boy, these are terrible variable names. I'm going to clean this up in such a nice way so soon. We've really got to get to it. I am going to say that, and I'm getting some information. I'll come back to that. There's a lot breaking news from the live chat. More information about the origin of this, but I'll come back to that. Okay, so let's say R. Oh my God. Let's make this R1, X1, Y1. Let's just at least make this make some amount of sense for a second. X2, Y2. And what I want to do is I want to say R sum equals R1 plus R2. And then X2 equals R sum times cosine of some angle. And Y2 equals R sum times sine of some angle, right? Because what from button press. What I want is to rotate this around. So I want to do this formula, but this R is actually the sum of R1 and R2. So now what I'm going to do is do this, and I'm going to say the angle is 0. So I'm going to start with an angle of 0. And now, whoa, that is way off. Way off. What mistake did I make? Okay, let's look at this. R2 is half of R1. R sum is R1 plus X2 is R. So it's right, but it needs to be offset by where it originally was. So this is just the offset from the center of R1. So X2 really equals X1 plus this, Y1 plus this. There we go. So now the circle's in the right place. Now let's make this angle a global variable, and let's say angle plus equals 0.1. And we can see, there we go. So we now have the circle rotating around. So this is the core mechanic. I could have done this in a much simpler, I don't know if it's simpler is the right word, but with less code and less math. I could have just used translate and rotate and achieved the same effect. See my other video about how to do that. But one of the reasons why I wanted to do it this way is I have full control. Like I can now draw a path. So I'm going to just add something to this. I'm going to say array list p vector path. So what am I doing here? I'm using a data structure that's a Java data structure called an array list. It's like a flexibly sized array, and I'm going to fill it with p vector objects. P vector objects are two-dimensional or three-dimensional vectors, an x and a y, and an x, a y, and a z. So what I want to do in setup then is I'm going to say path equals new array list filled with p vectors. And then what I want to do is every time I rotate this, I want to say path.add a new p vector at x2, y2. So as this thing is going, I'm going to store all of the points to keep track of a path. And then at the end here I can say for every single position in the path, so this is a nice Java enhanced for each loop. For every p vector pos in path, I want to say set a vertex at pos.x and pos.y. And I'm going to say begin shape and end shape to make this one continuous path. And now we can see this. So whoops, we can see that it's tracing its path. So we've got the core idea down from the Benesse equation, the orbital fractal, which is that we need to have some way of positioning a circle outside of another circle, rotating, and then keep track of the points of its path and draw something. Okay, so we're good. Now, we've got a serious problem here. This is not sustainable. Right? I could maybe do some kind of like weird for loop here and kind of just keep building on the previous one, but I don't, that's a problem. So what I want to do is this really going to work? Well, we're going to give it a try. I might have some angle issues, but what I'm going to do is what I need is to make this into an object. So let's think about what this is going to be. Like what do I mean by that? So quiet all of a sudden. This is a little edit point that I can stop for a second. I'm just going to look at the chat. Okay, Daniel Dale Benesse, author of more than a dozen math textbooks. So I think I should record something at the beginning that covers that. Okay, so what was I saying? I'm going to turn this into objects, something. Okay. So let's take a look at what I mean by that. So I need an object to keep track of what? I need an object to keep track of a circle that has, so each circle, let's call it let's call it an orbit. I don't know what it should be called. I'll call it a circle because I'm confused. It needs to have an X, a Y, and an R. And then it would have like a child. We can think of these as parent-child relationships. This is the parent of this circle, and if this one has one going around it, this is the child of this one, and if this one has a little one. So as this one, so that's what we can think of. Now, it also probably needs, it probably needs to know, have a reference to its parent so that it can pull its parent's radius. And then it also needs to have some type of orbit speed. So I think I could call each of these an orbit. An orbit has its current xy, it has its own radius, and it might have a child, it might have a parent, right? The first one has no parent, the last one has no child. So I think this is a structure of each object that we can build. I think this is going to work. I'm sure you guys can think of better ways to do this. Okay, so I'm going to make a new tab here in processing. And I'm going to name that tab orbit, and I'm going to write a class to create an orbit. And I'm going to say each orbit has what? And I could use a p vector to describe its position, but I'm just going to use an x and a y here. So it needs an x and a y. It needs a radius. That's its own radius. And it needs what? It needs a parent. Its parent is another instance of an orbit, and it maybe has a child. I could call its parent its sun, and the child its moon, but let's just use, I think parent and child will be easier for me to remember. And then what else did I say? Orbit speed. Okay, so it needs, I'm just going to call it speed. Oh, and guess what? It also needs an angle, right? It needs to keep track of that angle. So angle and angular velocity is really what we've got here. Okay, so all of these things are all of the properties this object needs. So when I make an orbit, I can maybe get, now this is like a kind of annoying convention that I follow, but the arguments to a constructor in Java are variables that are kind of like temporary. These are arguments to the constructor, but I'm going to use them just as temporary variables to fill the actual instance variables of the object itself. So I kind of just name them with an underscore to mark them as different. But I realize this often looks kind of cryptic or confusing. But let's do this. And then if I'm making one, I would assign myself as a parent. So parent equals p. So let's think about how so something like this might work. Like I'm going to make an orbit, is going to have an x and a y, it's going to have an r radius, and it's going to have a parent orbit thing. So I'm going to comment all this out, because we might need it again later. But what's interesting about this is I don't actually need an array of all of the orbit objects. I could make one, but each orbit object is simply going to keep track of the next one. So to iterate through them, I can just go to one, which points to the next, which points to the next. And this is actually, somewhat by accident, a data structure called a linked list. So we're kind of programming a bit of a linked list here, because each orbit is linked in like a list format. So I'm going to say orbit, and I could call it root, like it's the core, but I'm going to call it sun. I'm going to call it sun. And I'm going to say sun is a new orbit, and it has an x and a y, which is the middle. It has a radius, which is 100. And what else did I say it needs? It needs a parent. And this one has no parent. So I'm going to say null. Now, I could do something. Here's an interesting technique in Java. I could actually overload the constructor. And actually, let's do this just so you see this. You can actually write for an object multiple constructors. In JavaScript, you would just have one, and you would query the amount of arguments. But I'm going to do it this way. I'm going to write another constructor that does not have the fourth option. And I'm going to say this, which means call a different constructor with x, y, r, and null. So meaning if you ever create an orbit without the fourth argument, it just does the other constructor and sends it null. There's not really a major point in me doing this, but I don't want to have a parent for the original one. So now one thing I definitely want is I want some sort of display function, which these days I'm calling show. And what I want to do in the show function is say stroke 255, stroke weight 2, and then ellipse at the x and y with r times 2, r times 2. So now, if in draw I just say sun.show, if I run this again, we should see there it is. Now, how come, I guess I forgot no fill. Sun.show, there it is. Okay. I don't know, how long have you been watching this video and all I've got is a circle on the screen? I'm very, very sorry. But I'm hoping this will get more interesting soon. Okay, so now what we need to do is we probably want to say, how do we add a child? Maybe what we should do is say sun, let's just write a function to it. Sun.addChild. I'm just going to write a function called sun.addChild. I'm going to write a function called addChild. So I need to write addChild. What does addChild do? Okay, so first of all, it has a child. So I'm gonna set child explicitly to null here. I'm gonna set angle to 0 and angle speed to 0.1, just to give those some values. So adding a child means I don't want it to be null anymore. I want to say child equals new orbit. Now I need to give it an x and a y, a radius, and a parent. Okay, so the x and the y, so first of all, I should say new radius equals r times 0.05. So I'm just going to divide it by half. There's probably some appropriate ratios I'm supposed to use, but I'll just try dividing it by 2. So I want the new orbit. Now I need to get those x and y points. So a new x should equal x plus r plus new radius, right? Because I just want to offset it by its own x plus its own radius plus the new radius. And new y will just be the same. So I want to create a new orbit at x, new y, and I want a new x, new y with new r. I'm just going to call that new r just for a little bit more shorthand. And then its parent is this. So I'm having the function itself, I'm having the object itself create its own child, and it's going to pass a reference to itself to the child so that the child then keeps track of the parent. Good? Okay, so now let's see what's happening here. So now what if I say, orbit current equals sun? Why? I'm going to have to sort of type this out. So what I want to do is I want to write a loop. I want to say, show all the orbits. So start with the sun, draw it. Look at the sun's child, draw it. Look at the sun's child, draw it. And when eventually one of the children has no child, then stop. So as long as current is not equal to null, say current.show, and then I'm going to say current equals sun.child. So this is now an algorithm I have, look at this, for saying, look at start with 1. This is iterating through all of them. It's kind of like, I probably should do something like, write a function that returns it called next or something. But just for simplicity, I'm just going to say the current equals its child. So start with current equal to sun. It's not null, so show it. Then get the child. Is it null? It's not, then show it. Then get the child, and this should say not sun.child, current.child, right? Because I'm really, in a way, maybe I'll call this next. While next is not null, go to the next child. Something like that. Doesn't matter whether they call it current or next or whatever. The point is, it's a variable that's iterating through all of the things. So let's see what we get now. Awesome. We've got the sun and its child. Now, what if I have this actually also return the child? So in addition to creating it and assigning it, it returns a reference to it. Because then what I could do is I could say orbit child equals sun.addChild. Now this is terrible, but I could then say orbit child2 equals child1.addChild. Something like that, right? So this is this idea of like, I could have the sun create a child, and then the child of the sun create a child, et cetera, et cetera. So I probably want to write a loop there. But you can see, now I've got a bunch of them. This is pretty good. This is looking pretty good. Okay, so why don't we do this? Why don't we do this a certain number of times, 3 times? And I think we can employ the same sort of idea where we can say, and this needs to be an integer, where we can say orbit next equals sun. So next equals next.addChild. Right? So this is a little loop to start with 1 and then add a child, get its reference back, do it again, do it again, do it again. So this should give me, oh right, because I started with the sun, then I added 3 children. So you can see I was like, why do I have 4? I have 4 because I did it 3 times, but I started with 1. And we could even see here, this should probably be a parameter, but if I made them much smaller, like 0.2, well, that's a bad idea. Let's just leave it at 0.5. So this is good. So you can obviously play with this. Okay, now, interestingly enough, I just want to show you something really quickly. What if I just change this to a minus? Look what I got there. So that's interesting to see, a little quick variation, right? Instead of offsetting it out by the sum of the radii, what if I offset it out by one radius minus the other? That's going to give me a circle inside. So that's something that a little variation that you might play with. Okay, now, what happens if we want these things to rotate? Is this just going to work? What if I write in the orbit? Okay, so I need to write a update function. Update function. So first, what did I do back here? I kind of figured out this algorithm here. Let's grab this algorithm. So our sum, in this case, is now the sum of my own radius plus my parent's radius. Then the x should update to be the parent's x plus the sum times cosine of the angle, right? And the y, so this is updating, should be the parent's y plus the sum times sine of the angle. So this is me updating its position every frame, right? I want to look at I want to offset my location based on the parent's xy plus whatever my rotation is and the sum of the two radii. So that should update everything. And then in addition to that, I want to say angle plus equals angle speed. Or what did I call that? Just speed. So I always want to increment the angle. I have a feeling there's a mistake here. So that should update. So let me just run this. No syntax errors. I think I'm missing some pieces, but let's throw caution to the wind. And as we iterate through them all, let's also update them. Okay, what's wrong here? Okay, I've got a null pointer exception. Why? Because I don't want to update it if it has no parent. So I'm trying to, the parent never moves, never spins. So it's really only for the sun. So I'm trying to, where I put the, one thing I could do, there's a bunch of ways I could solve this, but probably a good way to do this is just to say if parent does not equal null. I'll just do this right now, just to make sure it's not a null parent. Then I'm going to actually do this. Okay, interesting. Now, why is it doing that? I have a feeling it's doing that because they're all spinning at the same exact speed. Let's see if I can create another. I'm going to create another argument here, float s for speed, and I'm going to say speed equals s. And actually, before I even do that, let's just give them a random speed. Let's just try a random speed between 0.01 and 0.1. And forget about this for a second. So let's give them a random speed. Hold on. Let's see. Now let me think about this. Can we pause for a second? I need a moment. I'm gonna have to edit this. Let's see. I'm thinking. The exterior circles, the opposite rotation. I'm looking in the chat to see if someone's just gonna point this out to me. I kind of have a sense of what the problem is, but I'm not completely seeing it. Okay. So I think let's make sure everything is being updated. Line 22. Okay. Line 22, angle is not. Oh, it's the parent's angle. Well, that doesn't really matter. Speed is assigned twice. Oh. Thank you. Yeah, okay, there we go. Okay. Thank you. All right, let's just pretend. We'll find that. Whoops, speed. Whoops, speed is assigned twice. So I need to get rid of this and leave these random speeds. Let's run this again and see. So you can see now we're seeing some like slightly different offsets from each other. Now there's probably an exact science to this, and they all also, there's a bit of an issue where they all have the same angle of rotation. I am looking at the YouTube chat right now. Speed reset to 0.1. So I think I want to look at the original version of this again. Let's pull that up. And let's see if we can kind of uncover what the relationship is between. So first of all, this one is moving, so they're moving in opposite. That one's moving, this one is moving counterclockwise, and the other one is moving clockwise. So this would be something to do. So let's actually think about that. So I have a kind of idea. Let's just actually leave them with the same. So first of all, let me add another, let's minimize this. Let me add another argument here. What I'm going to do is just give the first one 0.1. So I'm going to, there's so many different ways I could do this, but let's try to be a little somewhat consistent about it. Let's add a fourth argument for speed right here, okay? So let's make sure that works, and then speed equals s. Now they should all have exactly, whoops, and here I should pass in, speed. So now they all have the same exact speed, and that's a little bit fast. I think it'll be easier to sort of figure this out if we watch it a little bit more slowly. So let's start with just kind of like 0.04 or something. Okay, that's a little bit easier to look at. Okay, now let's just try a simple idea of when I make the child should have the negative speed of the parent. Same speed but opposite direction. Now this looks more like something. The question is this exactly the path that is, and you can see, is this exactly the path? Yeah, speed is actually angular velocity, someone in the YouTube chat writes, which is a good point. It seems that speed is I minus 2 times the parent speed. So maybe it actually is faster, but in the opposite direction. So let's try that. Yeah, this looks so, but I've started with it too fast. So let's try it as much slower. Yeah, this looks good. So I feel like this looks much more like what the original program had. So now, did the original one also have a total of 4 circles? Let's see. Let's look back at that original example. And I can't see. 0, 1. It also looks like they're shrinking more by like a third. I can't exactly tell, exactly. But it looks like there's 4, and it looks like maybe they're shrinking by a third. So let's divide it by 3 and see. So this looks much more like what happened there, and I think we can also start the original one at 200. I guess that's a little bit off this window, so let's try 150. There we go. So now I think we've gotten kind of exactly what's in that thing. Let's try tracing the path. Okay, so all we need to do is we need to have a reference to the last one. So what's the best way for us to reference the last one? When this is done, next is null, unfortunately. So I think, I'm trying to think here, what would be the best way? I mean, I could obviously I think what I'll do is, just for simplicity, is I'll just keep track of a global variable called end, and at the end equals next. So the very last child is the end, and then I can actually just go back and add this path stuff exactly back in, and I can say n.x and n.y. So this should now be that path, and let's make the path, I don't know, pink or something, or purple. Let's make it just so we can see it, and let's also make the orbits, let's make them maybe a little bit lighter. Give them a little alpha, and let's see what we get. Well, that's certainly something. But I obviously have the ratios. Oops, okay. It's good that we have a pause. I'm seeing some good points in the chat. Irakli says change speed to -3 times speed. Let me make the stroke weight a little bit more visible here. And we can now see how it's tracing that path. It's kind of nice. Doesn't look like that fractal pattern at all. I'm seeing in the chat that I'm being suggested to multiply it by -3. So maybe I just had that off. -3. Let's try that. There we go. So this looks more like that pattern. And second circle has 5 times the speed, and last has 20 times 4. So I think how those speeds are changing is actually, we can see what kind of patterns. That's times 4. I think they're actually almost exponentially increasing. Size divided by 3, speed times 3. Speed inversely proportional to the reduction of size. Time for some sliders. So what do I do to get this exactly right? Everyone has so many good suggestions. Those of you watching this archive are probably screaming. Let's have a pause point here for a second. Because I want to think about this. It probably, does it say somewhere on this? It must be exponential, right? So if I did something like speed times speed, like it's squared. Oh, no, because that's no good because it starts so small. Put variable into cosine and sine, more children, comment section. He explains it in the comment section. Okay, that would be useful to look at. Okay. Speed of n equals k to the n minus 1. And then alternating the sign. K is plus or minus. Okay. So let me come back into the video. And let me get back to where I was. So several people in the chat are pointing out to me that if I just bother to scroll down onto the original web page, the formula for how the speed is increasing exponentially is on the page. So if I go over to the page, we can see it right here. Benice posts speed of n being the level 0, 1, 2, 3, 4, equals k, which is to the n minus 1. So k alternating the sign and starting with 2. So let's see if I can implement that. So what I probably want is maybe for each one to have an n. So let's give it an n. And the first one's n equals 0 because it has no parent. No, hold on. N equals, let's just give it an n, and I'm going to add that as another. I'm kind of overdoing the arguments here, but I'm going to add that as another argument, and n equals n. And so start the first one as n is 0. Right, the first one, n is 0. What did I get wrong here? X, Y, R, int n. Okay, X, Y, R, S. And I should really be consistent about this. So I'm going to do that just to be consistent here. So now I'm going to start the first one as 0. And then I'm going to, what did I get wrong here? Oh, int. I'm making it an integer just because by definition it kind of has to be an integer. And then I'm going to, when I create the child, I will say, give it n plus 1. Okay? N plus 1. Now, speed is actually not something I need to pass through anymore. Dare I delete this? So now I actually can get rid of this whole speed thing. because I can make that a formula based on n. And I can get rid of this. And we're going to say that speed equals k to the n minus 1. K being, oh, but I do need to alternate the sign. Oh, so I'll have to fold that back in. Let's just first get this to basically work. So I think of k as really just like n plus 2, or n plus 1, because the first one's going to start at 2, to the n minus 1. Power n plus 1 to the n minus 1. Does that make any sense at all? And probably convert that into radians, because that's going to give me kind of a big number that's in an angle. And so, yeah. Okay. So this now, look what I'm getting, but they're not, this looks kind of more right, I think, but they're all going in the same direction. So what I need to do is use modulus. I can use modulus, thank you to Clemensopoli94 in the chat. So what I can do is I can determine whether it's positive or negative based on n modulus 2. So I can say direction equals n modulus 2. So I'm going to get 0, 1, 0, 1. And then if direction, I'm sure there's a much easier way of doing this, equals 0, direction equals negative 1. So whenever I'm going to get 0, 1, 0, 1, so I'm either going to have it be negative or positive. And actually, at first, yeah, so I think this will work. So now I need to say it's direction times. And let's look at this. And closer. What did I get wrong, everybody? Direction should be a Boolean multiplied by negative 1 to the n. What did I get wrong? Oh, this, hold on, let's look at the formula. This should be k to the n minus 1. Oh, so k is a k to the n minus 1. Hold on. Int k equals direction times n. Direction times n plus 1. Is this what I need to do? I'm pausing this tutorial here. I think that's the same result. Is it like 8 o'clock already? Oh my god, it's practically 8 o'clock already. This is going to be negative k to the n plus. If you use negative k, then the sign will alternate, yeah. So I don't even need this direction thing. But let me leave that in there just for right now. Whoa. You know what the problem is? I know what the problem is. I think my resolution is so small. And what happens if I add just one more level? Also, I think the fact that the speed, like, what if I do like divided by 100? No. No, that's way too slow. But is that gonna give me, okay, let's add another level. So first of all, I'm out of whack here. So let's take that out. So this, I think, is the right idea. The question is, let's add another level. Whoa. See, I feel like this is right, but it's so jagged. So maybe what I need is to do it, to have lower increments. But this is going to be incredibly slow. But I want all those points. So let me not divide it by 1,000. Let me just divide it by 10. And then I'm going to actually do this 10 times. I'm going to have to back up and do this again because I'm just thinking this through. Interesting. Do I have too many? Should I have done it with just 3 now? And, right, and what if I now do this 100 times? No, because it's I'm drawing the, I don't want to do the show 100 times. I'm making it run too slow. Okay, somebody's, are you tracing the edge of the circle and not the center? No, I'm tracing the center. Oh, the last circle from the edge, not the center. Oh boy. Okay, let me get rid of this silly idea. Let me get rid of this here. Okay, this is what I've got. And I'm tracing the center of the last circle. Should I be tracing... The other thing that I'm not convinced about is that these are actually correct. The ratios between the size of the various circles set the limits of the function expression being circle. How many circles? Oh, 10 or 11. Oh, there's just like so many of them, but I'm not seeing them. 10 or 11 circles. Hold on. Is that the issue here? 10. So yeah, does this look, let me go back to the, I think maybe I'm getting it, but the speed is, whoops. The speed, I'm going to look at the image. Now also, there is a 5-point pattern here. Did I do 10 or 11? That's 10. This is just a 4-point pattern. You don't, okay, it's still the same shape. Could you, K should be constant, not n plus 1. Oh, K, really? Oh, K is a constant? That would make sense. Hold on. Oh, those are different options. Okay. Forget this. Let's just make K. And give it -2, and then the power thing should take care of that. So now, so yeah, I think I'm getting something. Let's try 3. There we go. Right? This looks more like the image. There we go. Right? That's the same. I think I did it. K, a real... I think I did it. Sort of. So I got to backtrack. I was doing a tutorial. And then I like got lost and I was like, I can't be doing a tutorial anymore. I have to just figure this out. So I need to backtrack. Where was a point where I was, where was a point, and I know there's some there's a lot of fixing up of this that could be done because I have a feeling there's some, my increment values are kind of low, but this is pretty close. And you can see this. So I'm kind of close and I'm sure I could, okay. So if you guys can help me here, where did I last leave off where I was kind of wrong? So, I think it was before let me go back to where I look at the formula. Let me go back to where I look at the formula. So I'm going to do something very dangerous, which is a lot of undoing. Oh boy, this is bad. Oh, this is bad. Okay, nope. Maybe we're okay still. Oh, processing has an issue with undoing past a certain point. Like, let me just go back to, shoot. Before I have the n, and I just had the speed, get rid of this n stuff. Sorry, everybody. I'm going to go back to -2 times speed. And then I think this is what I had. And then here. And get rid of this. And what did I miss here? Shoot. Hello. Update function. Angle. Speed. Oh, speed is 0 here. Sorry. X, Y, R. Speed. Oh. Oh, look at this. X, Y, R, S. This is what I had. Shoot. Angle equals 0. Yeah. What's going on? Okay, I can debug this. So I'm just like, the definition of insanity is doing the same thing over and over again and thinking you're going to get a different result. I just keep running and thinking, oh, it'll work the next time I run it. Do I have like no loop in here or something? So let's just see here. What am I missing? Update. Print line. Hello. Is this happening? No. Oh, child equals this. Somehow I lost that, this. That's what I lost. Okay, oh, and now it's going like super fast. What did I have it? I had something like this, right? There was a point where I had something like this. And I only had 4 photos. Okay. All right. So I think now I'm going to this. I feel like I've had some really good live streams recently, and this is not one of them. Okay. Okay. So I'm going to go back to some point and come back in and look at. Oh, Mathieu is typing something. Oh boy, that'll be fun to edit. That's what I'm sorry. I'm going to go back. I'm just going to go back to looking at the formula in the chat in here. Okay. This is like me pretending something is happening. Okay, there was an awkward edit there, but there was a bunch of debugging things that happened that I was trying to get this right by just eyeballing it. And actually, the chat nicely pointed out to me that the formula is just in the comments lower down on the page. So I'm going to go back down here and look at the formula, which is right here. And it says, okay, so speed is equal to k, a constant, to the n minus 1 power, and n being the level. So the first circle is 0, the next one is 1, so n must be the level. And then also something that is important here is how many circles are there? Well, there's 10 or 11, and 100 or 101 for the first static image. So I'm actually, first of all, I'm only doing, oops, I forgot to undo this part. Come back, more editing. This is such a, I'm so sorry, I'm so sorry. I'm only using You didn't know. Where's the Men in Black thing? I am, this is my process, okay? This is not a good process. I need to rethink my process perhaps, but this is what it is. Okay. I also need to use 10 or 11 circles where I am in my code, I actually only have 4 because the first one is 0. So what I want to do is go and look, how am I getting the speed? So I'm multiplying the speed by -2. I think I tried a bunch of different things, so maybe where I last left off it might have been 4. We can see increasing the speed gives me kind of more interesting patterns, but really what I want is not, I don't want to be computing that speed. I did this already. That's why there's some stray variables in there. And I'm like backtracking so that you can watch something that's, but this is what it is. So, hold on. I don't know. What I want to do is rather than have the speed be this thing that changes, I want each orbit to keep track of its level. So ultimately what I want to do is just send in the number 0. The sun is 0. So I'm going to add a variable called n to keep track of its level. And instead of s, I'm going to pass in n. And I'm going to set n equal to that level. Then speed is going to be something that I calculate based on the formula. So if I go back and look at the formula, it is k. Now, I don't fully understand this, but k, I believe, is usually a constant. So I think maybe I can just sort of like pick one of these. So I am going to arbitrarily pick k of 2. And then I'm going to say speed equals power k to the n minus 1. Is that correct? K to the n minus 1, yes. And then when I create the next orbit, I just send in n plus 1. So the next one is the next level, and the next one is the next level. Let's just take a look at this really briefly. And why is this giving me, oh, this should be an integer. I'm using integers for the level. And same thing here. Not that this really matters that much. So now, whoa, something is way off. Okay, here's an issue. These values are very large. And that's so one thing I could do is just maybe think of them as angles and convert them to radians. And now we've got something that more. Now there's a couple problems with this. First of all, I'm getting a pretty interesting shape even just from this. One thing that I need to do is I need them to alternate their direction. So the nice thing about setting something to the power of an integer is that if it's a negative number to the power of 2 squared, it'll be positive. To the power of 3, negative. To the power of 4, positive. So I can actually just say k equals -2. And now they're going to go in opposite directions. And you can see this kind of looks remarkably like what I started with. But let's try having this k be something larger. And we can start to see now that this resembles much more closely to the pattern that we saw in this original image. Now, I'm not getting so much detail here. And I think the way that I'm going to get more detail is by actually having many, many more levels. There's only 3. Let's add 10. And now we can see, now my incrementation steps are kind of large from that conversion to radians. So there's probably a way for me to have the time steps be smaller so I can get more detail out of here. Because, this would be interesting to try adding 100 of these. But it can't even, I don't know, maybe let's just try adding 20. But my incrementation steps are so large that I'm not getting that level of detail. So we've got something that kind of resembles it. I suppose if I wanted to really trace it out, I could have the incrementation steps be much smaller. Maybe I could just divide by 1,000, but add like 100. It's going so slow. So I'm going to have to speed this up and time-lapse it. I'm going to leave that to you as a challenge. So the challenge that you should do, and maybe I'll come back and revisit this in a future challenge. Let me get this back to a state where we get something, is to take this basic idea and more closely match the level of detail in these images, and also think about how can you adjust how the circles are positioned relative to each other to change, to get these different kinds of patterns. And I would read through this entire page and see, look at some of these kind of amazing, crazy patterns, and see what you can get, see how you can color it, see what you can do. And these are, I'm loving this already. I just want to, let's try one more thing. Let's at least try the thing where we nest the circles inside of themselves rather than outside. Whoops, that didn't work. Sum, where's my sum? That's what I'm looking for here. Yes, so let me say minus here with the sum. And now we can see this particular pattern that's very similar, but now sort of more inside of this particular circle. Okay, so thank you for watching this coding challenge. I have no idea if this was interesting or useful at all. I feel like there were some nuggets at the beginning. If you've made it to the end of this, hashtag trainwreck, coding trainwreck, I think is the new appropriate hashtag for this channel. You can tweet me at Schiffman, hashtag coding trainwreck, with your non-trainwreck beautiful visualizations that you've made from this Benice, I don't know how to pronounce it. Somebody will tell me, I'm sure, in the comments. Equation, orbital fractals. Thank you for watching. Okay. All right. Coding train wreck. Okay. So let's think about this. So I think I need to go back and make a little intro to this to kind of apologize for the awkward edits, and also to mention, to find out some more about. So somebody in the chat, if somebody could repost the full name of the mathematician whose website this is. Mathematician Benice. No, that's Venice. I did not mean mathematician Venice. I'm waiting for the chat to catch up to me, I guess. You're like 20 seconds behind. The coding train went off the rails. That's definitely for sure. Nobody will help me with this. You were all posting it before. Please. Please. I'll play my lullaby music, which is so loud all of a sudden. Daniel Dale Benice. Thank you. Okay. Oh, there, it's right here. Daniel Dale Benice, author of many books, math books. Let's not worry about that right now. Is there visit this page? Okay, let's see. There we go. Okay, and this is this mathematician's blog. Professor at Montgomery College, Rockville, Maryland. Thank you for that. Okay, this is great. So what I'm going to do now is pull this up. And let's backtrack it out to this. I really want to, how do I get more detail out of this? Is it just like letting it, is it just, I'm like, this is driving me crazy. That I feel like this should definitely work. That if I just, maybe if I were to, like, what if I don't show the circles just for a second? Oh, look at this. And say no fill. Sorry, I'm off the rails again. Coding train, choo-choo, off the rails. Okay, so that's that. What if I were to, like, for example, if I were to just do this 10 times each frame, I would see the exact same, and I have to add all the path points. I would see the exact same pattern, but it would happen much faster. So if I were to increase the speed, decrease the speed by 1,000, and then do this like 100, yeah. The camera went off. There we go. There we go. And this is also way too extreme. So let's just divide that by 100 and do it 100 times. There we go. I was trying to do this and I somehow had like some kind of performance anxiety issue where I couldn't get it. This is exactly, it's a little bit offset, but this is exactly the image. Oh, perhaps Daniel Dale Benice is no longer alive. Let's look at Daniel Dale. I don't want to preemptively announce anyone's Montgomery College. So if anybody can determine that, maybe you guys are better at Googling than I am. Okay. Now, how much will you guys all, what do you think about me just going back in time? I think that this, fix the starting angle, yes. That this, I will do that. I would like to, I'm going to go back in time. I guess I could just do an addendum. Or I could just go back in time. I feel like this should make it into the ultimate video. So I don't know how to do this. Poor Mathieu. The good news is there's just going to be one video to edit. Since apparently all I'm able to do, it's practically 8 o'clock. This is 1 hour and 40 minutes. I'm still on the first coding challenge. I said, I'll just do this in 15 minutes. This, by the way, this is, if I would just do these in advance, I could spend a couple hours. I would have sorted this all out, and then I would have just like come in here and looked like I know what I'm doing, which I probably should do. Yes, I'm going to not. Okay. Yeah, I know people want to look at matter.js, so that might have. I might come back and do like a bonus live stream like on Monday or something, because I don't know. I'm going to lose time and energy at a certain point, but. Maybe we can try to do one more thing today. Okay, so let's figure this out. Let me backtrack to where I was. Okay, this is where I was. Now there's some theories that Daniel D. Benice is not the same person as the blog. That's quite possible. So maybe, how can we, yeah, that doesn't seem so unlikely considering that these are posts as of July 2014. Oh, wait. As of July 2014. Oh, look, there's also this equation. So maybe we don't know. Maybe I'm just going to leave it as is. And I think I'm just going to do an addendum. Maybe it's just named after the mathematician. That's possible. See the bottom of the blog? It says copyright Benice C.J. Chen. Okay. Okay. This mystery. Yeah, C.J. Chen. Okay. That's clarifying. So I still don't know who this person is or why they're called Benice, but maybe they're named after that mathematician. I think I'm going to leave this as this. Okay, here's what I'm going to do. I'm going to do a little addendum to the video. It will just, after my little train wreck nonsense, I'm going to come back and I'm going to thank everybody in the chat who's been so nice and thoughtful. And I'm going to say I'm going to recode that part that makes it more like the original. We're going to do this twice. Okay, so come back to here. And then I will probably do another. I will do another intro. Boy, this was a rough one. I gotta start. A lot of people commented on Emily's guest video of how well prepared she was, and it was kind of refreshing. Some people, I think there's a question as to what style you prefer, the more prepared and style versus the unprepared style. I think now we're seeing the absolute opposite extremes. Maybe there's a little sweet spot in the middle, which I will continue to aspire to. Okay, so here we go. Oh, hello. This video is not over. Lest you thought the train wreck was finished, it is back. And I'm going to do a little quick addendum because I had some very nice, thoughtful, and helpful messages from folks in the live chat. And I think it's worth taking an extra minute or two of your time to try to get my version of this to look much more like the one that's here. And you can see it's tracing itself over and over again, but I don't have the level of detail, quality of the image here. And I also, it's driving some people a little bit mad that it is offset by a sort of strange angle. So first, let's fix that offset. So the angle at first starts at 0. So I believe if I just start at I don't know, let's guess. What do you think it is? Like 45 degrees? Is it off by? Nope. Oh, I got close. What is the correct angle of offset? Minus? There we go. So I'm a little bit off still. Oh, no? Wait, hold on. We're going to do this again. Do over. Coding train wreck. Coding train wreck. Okay, someone will make that in a song. Minus pi divided by 2. Is it really? Was I just being? It's like, no, it's not. Hold on. 0. Let's look at this. Let's evaluate this. Pi divided by k plus 1. It was correct before I started undoing it. Really? I like this. Pi divided by k plus 1. That's interesting. Whoa. That's very magical to me, but that's not right. What was it supposed to look like? It should have this facing straight up. Negative pi divided by 4 is my first guess. This is the original, right? Where this is, oh, you know what? It's just starting at the top. Hold on. Oh my goodness, I'm a doofus. Everything's going to be okay. Here's what we can do to fix this. Let's actually offset the y. Right? I really want to just do this. To have them start facing up with the angle at 0. What? Nope. Right? They should be starting up. Let me run it again. Wait. Hold on. Let's not have it rotate. No updating, please. Oh, minus. That's how it should start. Oh, but the angle. I see what you guys are saying. That's starting at the bottom, pointing straight down. So could I really have just rotated it by, and now, hold on. I think I see what you're saying now. Negative pi divided by 2. Oh, it was right all along. You were telling me this. Delete everything. Negative pi divided by 2 was right all along. Oh, I'm the worst. I told you. Somebody take over this channel. I quit. Fire me. I got to get to the choppa, or whatever the new thing is. No, I did not watch that show, but I just know the line from it. Okay. Okay, we're going to start this whole thing over. Everything's going to be fine. x plus r plus new y equals y. It was right all along. I'm just a lunatic. Of course it's negative pi divided by 2. I mean, I had a very long day, a very long week, operating on not very much sleep. Okay, here we go again. And I put pi divided by 2. Okay. All right, let's try this again. Where are my tissues? I found an extra one. Maybe I'm not hydrated. I'm not hydrated. Okay. Here we go again. I don't even know what I'm doing anymore. Okay. Okay, I'm back. For like the 10,000th time for a quick addendum. This train wreck is not finished. I got some wonderful, nice comments in the chat, and I would like to improve. I think it's worth taking an extra minute of your time to improve my particular drawing to match more closely what's going on here. So first of all, the first thing, and I'm sure everybody this is bothering a lot of you, I know, which is that I didn't actually line everything up with the top. And you'll notice that if we look at mine, it lines up perfectly to the right at the 0 angle. So I just want to go rotate negative pi divided by 2 at negative 90 degrees. So first thing I can do is just very quickly fix the angle to be negative pi divided by 2. And in this case, now we at least have the pattern pointing up. Now, one of the reasons why we don't have the same level of detail that's here is that my incrementation amount is quite large. So as it moves, the rotation is happening fast, and I want to see this play out in real time. But if you'll notice, this has a kind of like stuttering. I mean, it's a GIF, so there's probably some issues with how that's done. But this is actually probably, each time it moves, it's kind of drawn a whole lot of points. So I can emulate that. So I'm going to make a global variable, which I'm going to call resolution. And I'm going to set that resolution right now to 1. So what I want to do is look at the speed, and I want to divide the speed by resolution. Meaning, how many incremental steps do I want to take in between each angular change of that angular velocity? So maybe I just want each time step is like a full unit of 1. So I want to divide by resolution there. And then what I need to do here is each cycle through draw, I want to do this same updating the path n amount of times, that resolution amount of times. So I'm going to write a for loop here to do this n amount of times. So there's a little bit of an issue here where I'm going to be drawing the circle multiple times, but I want to get all those incremental path points n amount of times. Now, resolution amount of times. I shouldn't use n because that's being used somewhere else. Now, if I run this is exactly what I had before. Now, I could, if I wanted, take this out. I kind of did this all at once because I practiced this a minute ago when I was debugging. But even if I just change that resolution now to something like 10, what you're going to get is you're going to see this giving us a finer level of detail, but it's going to be running more slowly because the whole animation is doing kind of 10 steps. So one way I can kind of clean that up is I can do 10 steps each cycle through draw to keep that same speed. The one thing you'll notice is those circles look much brighter because they've been layered on top of each other a bunch of times. I mean, one thing I could actually do is just not bother to draw the circles, and we could just see the path. And there it is. And I probably should also stop it from redrawing when it gets around to full rotation. So you can see it's kind of drawing over itself, but you can see this has much more like the quality of what's in the original image. And just to sort of see, if I make the resolution 100, does this really give us anything better? I'm not sure, but you can kind of see now I've got even more levels of detail. So the number of levels of nested circles and that resolution, it would be, I think, a great thing to try making this very high, blowing this up and making this a large pixel area and trying to really see how detailed can you make that and make a kind of like a high resolution image version of this. Okay, so thank you for watching this coding challenge. I think there's a lot of exciting creative possibilities that you could build off of it if you were able to follow this. I will post, in the GitHub repository, I will post both a processing version of this and a P5.js version of this that you can run in the browser, and I look forward to seeing what you make. Thanks for watching. Okay, so now I need to go back, and I'm going to make a quick intro. CJ Chen. Ooh, that is lovely. That Alka, look at that. Is that something you found on the page, or did you just make that? Set the speed to negative to get it the right way. Oh, it's going the opposite direction. I can't get anything right. Look, I think it's fine going the other direction. You can do that yourself. Okay. Oh, Google Images. Okay. So start over. Should I just do this whole thing over? That would be interesting. If this is a total disaster and can't be edited and uploaded the way it is, I'm happy to redo the whole thing next week. I bet you I could do this in 20 minutes now that I know how it works. Oh, is my audio out? I'm seeing some people saying my audio is out. Is it okay? I need to hear okay audio in the chat before I do this intro. Also want to make sure I have no emergency messages on my phone, which I don't. Okay. Okay, the audio is fine. Okay, great. Okay. Okay. Oh, hold on. Let me get this. The noise in the hallway has come back. Okay, I'm going to do a little intro to this coding challenge. Hello, welcome to a coding challenge, and I'm probably going to say, I might say hello, welcome to a coding challenge again, because I just did it, and I feel like I need an extra little intro here to let you know that what you're about to watch is going to have some rather awkward edits in it. I actually spent about an hour and a half, I would say, maybe, kind of building this up, because I had a bunch of issues that I wasn't sure about. But as you can see, this is the final result, which matches quite closely this particular fractal spirograph pattern from this blog called the Benice equation.blogspot.co.uk. I believe this is a blog run by, and I said at the beginning I don't know who this is, but looking down here, this is thank you to CJ Chen. I believe that the blog is from CJ Chen, and so I'm going to just, without further ado, start this coding challenge. I should also mention that this video is going to seem like it's going to end, and then I'm going to come back again. Because when it ends, I don't have it exactly like the picture, and then I come back and add a few more things. So this is probably a pretty long and awkward coding challenge, but I hope you enjoy it, and I hope you make some stuff with it, and share with me what you make at Schiffman on Twitter. Thanks for watching. Enjoy. Okay. The hoodie string, yes, is in my shirt. Well, on the other side. Okay. Sorry about that. Okay. Cho J. Chen. Thank you. Is just a be nice, not a real name? Is that true? Cho J. Chen. Cho J. Chen. Alberta. Are you telling me I have to do this again? I'm going to do this again. Ah. And is be nice just be nice? Maybe just be nice. Is that true? Angus is asking, when will I introduce ES6 into my P5.js videos? Around when I do Chrome extensions, I think, which hopefully will be very soon. Does anybody know if it's actually be nice? Because we should do a live, no, I don't think I'm going to call. Okay, I am going to redo that intro again one more time for the live audience. This, I think maybe I need a new process. I don't know. I'm going to think about it. I definitely need a new audio system. This AirPlay thing is not working for some reason. Okay. Be nice. Or maybe it's named after a mathematician. I don't know. That I'm going to leave as an unknown mystery. Coming back. One more time. Chojie Chen. Okay, here we go. One more time. Hello, welcome to a coding challenge. This coding challenge is going to start a couple times and end a couple times. When you watch it, it's going to be rather awkward, a bunch of awkward edits. I had a kind of long debugging session in the middle of it, a couple different times. Thank you to everyone who watched this live, who helped me. And if you want to see the full, much longer live version, I don't know that you really want to, but if you want to, find a link to that in this video's description. So what I'm going to do in the coding challenge is an attempt to recreate this exact effect, Fractal Spirograph. It's on a blog called the Be Nice or Be Nice. I like to think of it that it's actually just Be Nice-equation.blogspot.co.uk. From the chat, thank you for this research. It believes to be a blog maintained by mathematician Chojie Chen from Alberta University, I think, University of Alberta. So thank you for, and if you look, there's a lot of wonderful variations on it that if you follow this coding challenge and implement your own version of it, you should be able to create. So I'm excited to see what you share, what you make of it. Please share it with me at Schiffman on Twitter. Enjoy this very awkward, strangely edited coding challenge that will start twice and end twice. And I look forward to, I've said this like so many times, I'm afraid of time traveling into the actual part where the coding challenge happens. But it has to happen right now. All aboard the coding train wreck. Okay, I think we're good. Okay, I'm looking at myself. I think we're good. We've got a thumbnail maybe for this. Maybe sometimes with the thumbnails, it's nicer to have this over here, and I stand over here, and I point this direction. We've got the thumbnail. First of all, whatever, okay. I don't know. A lot of different thumbnails there. There you go. Okay, so this was a 2-hour live stream dedicated to the Be Nice equation. I learned a lot. 8-bit engineer in the chat writes, don't beat yourself up. You learned a lot along the way, as did we. And, oh wait, people think it's not that same professor? Oh no. Yeah, this looks a little, boy, it might not be the same professor. Actuarial science. It also very well could be. Maybe it's not meant to know. I don't know why I'm trying to research this in such great detail. Benice, Italian. Oh well, I don't know. I don't want to bring up this random person's webpage if it's totally unrelated. And I also maybe don't want to violate this person's privacy and show their image. So I mean, it's on the live stream. So, but I think for the coding challenge, I think for the coding challenge, maybe just use that first intro where I just reference CJ Chen. There's too many, right? Because this is like UK and that's Alberta. It's got to be wrong. This is a mystery, by the way. I would really like to solve this mystery. Now, I don't want to solve this mystery if it's not meant to be solved. I just wanted to give credit. But sometimes people post blogs and would like them to be anonymous. And maybe, so here's the thing. Nobody has, yes, there's no reason to believe that's the same person. Click on CJ Chen at the bottom of the blog. That's a link, it's not a link. This is Groundhog Day. Insane, crazy Groundhog Day. You are watching Coding Groundhog Day. I hope nobody ever comes back and watches this, but you are the live stream. You are here with me on this journey on the train. We're going to do this one more time. Because we can, and we will. And we're not going to include this random professor who probably has nothing to do with it. We don't even know if this has anything to do with it. We're going to leave this as a mystery. I don't think it's meant to be discovered. We found something inspirational. We recreated it, and that's what we did. Okay. Last time. Hello! Welcome to a coding challenge, Fractal Spirograph Day today here on the coding train. Choo-choo, all that sort of stuff. So what you're about to watch is really awkward and a little bit odd. It's going to have some awkward edits in it. I had several long stretches where I got sort of stuck on a debugging problem. If you're interested in that longer debugging process, you can go and click on, there'll be a link in this video's description to the long, almost like 2-hour at this point, live stream where I did this challenge. But what you'll see here is that I do have an end result that closely matches this particular image on this blog. So the blog is beneath-equation-blogspot.co.uk, and the creator of this blog is, thank you to CJ Chen, the creator, I believe, of this blog, proposing and describing some of these images. So this coding challenge is going to start twice because I'm doing this intro, and then it's going to actually happen where I'm going to introduce it again because I think that I don't need this intro. And then at the end, it's actually going to end twice because I'm going to finish and then realize and come back and add a few bits to make this more closely match the images on this particular blog. So I hope you make something creative with this. I really hope this has put something out into the world that's useful, because boy did I spend a long time trying to make this video with a lot of problems. And please share it with me at Schiffman on Twitter, hashtag coding trainwreck. Enjoy. Okay. Thank you, everybody. This is definitely the end right now of this particular coding challenge. I learned many lessons today, one of which is preparation. Coding Train, brought to you by being completely unprepared to do something and just figuring it out on the fly. 8 p.m. in New England. Yes, 8:17 p.m. here in New York City. The sound in the hallway has come back, so the party started again. Okay. What is realistic to do today? Let's look at this very sad. So let me just at least show you the examples. I don't think it's realistic for me to do much more. I'm going to show you. Let me come back here, and I have a new repository that I'm working on, and oops. Schiffman, I don't know what I just did. See, my brain is already completely fried. Repositories, P5 matter. So this is a repository that I just started working on this yesterday with an eye towards doing some of this in today's live stream. But what I'm going to do is work on this some more. Preparation. And I'm actually going to do this in my class next Tuesday. So maybe next Tuesday or Wednesday afternoon, I'll try to come do a bonus session. My regularly scheduled next week at 10:30 a.m. session will still, of course, happen, even though it didn't happen today. But next week I'm planning to do the morning time for all of you European folks who are watching this in the middle of the night, apparently. I'm going to come back next week and do an extra session on matter.js. So I'm going to give you a little tease or taste of that right now. So what is matter.js? Matter.js is a 2D rigid body physics engine. You can see here right now the homepage just cycles through a few little demos. So these are wonderful. The source code of all these demos is available. There's documentation. It works really well. There's all these possibilities. There it is. This is what it does. It's opening up your imagination, hopefully just seeing these particular examples. Now, one of the things that's interesting about matter.js is it has a built-in rendering engine. So you can actually just set up the physics scene and say render, and if you give it a canvas, it'll render to it. You can also customize and style it and add sprites and that sort of thing. But what my take on this is, what if you want to really have like full, total control over the rendering and without having to use just the JavaScript raw canvas API? And what if you wanted to use matter.js as your physics engine, but something like P5.js as your rendering engine? So that's what I've done in some examples that I've prepared, which are mostly just these exact examples, but using P5 as a rendering engine. Let me give some credit to, on Twitter, to the creator, of Twitter, matter.js. Leah Brew. Leah Brew on Twitter is the developer of matter.js in the UK, probably sleeping right now, thankfully, hopefully, and there goes the camera. Leah Brew actually answered a couple questions for me that I was stuck on Twitter. Thank you for that, at Leah Brew on Twitter. So I'm going to very briefly, I'm going to clone these examples and show them to you. So this is just a little bonus for those of you who stayed up this late. This won't go into an edited video. I'll come back and do that next week. And then CDP5 matter, open it up in Atom. And what I'm going to do here is run a local server, which I already am doing, or no, I'm not. And I'm going to go to these examples. So what I'm going to do is show you some basic stuff. So let's look at this basics. So just refresh again. So this is like the simplest possible example, and might as well practice this a little bit. So what am I going to do? Basically, the way that matter.works is that there are some core concepts. There is this idea of a body. There is this idea of a constraint. There's this idea of a world. And there's this idea of an engine. So you create a world. That world might have gravity in it. Maybe the gravity is pointing down kind of by default. So sort of global settings are things that exist in the world. A body is a thing that exists in the world like a rectangle. And you can create that rectangle, add it to the world. And the engine is the thing that runs the physics loop, steps through time. So if you create a particular body, add it to the world, start the engine running, then all you have to do is ask matter.js each cycle through draw, where is the particular body, and draw it to your canvas. Simple as that. Constraint is something that refers to, in Box2D it would be a joint, something that connects, could also think of it as a spring. So a constraint is something that if you have two bodies, you can connect them. And I'll show you some examples of that. So constraints are things you can add to the world which connect bodies. So if we look at this sort of basic example, and we come over here, this could actually be a tutorial video at this point. We can see that I'm just going to step you through the code, and I'll come back and build some things from scratch. But you can see, hey, I'm making a box, and there's some syntax stuff that's a little weird. Not weird, but that's, that you have to get used to and understand, sort of a JavaScript design pattern of like there's everything's namespaced. So I can call this rectangle function a part of the body's object, and I'm looking at what's posted in the chat. I don't know why that's in there. In a world, what is that? Sorry, I should not be looking at the chat right now. So the rectangle is at 400, is x and y is at 400, 200, and that's its size. Here's another one at 450, 50, and that's its size. And the ground is this other rectangle at the bottom, but I'm passing in this parameter is static because the ground doesn't actually move. And then I can say, hey, I'm going to make a world. I made an engine. I created an engine. Then I'm going to add all these objects to the engine's world. I think probably this example, I would probably, just for clarity's sake, want to make a world variable. That's just equal to engine.world. And then I'll probably change this by next week. So I want to just say, like, this is like a function add that's allowing me to add an array of these bodies to the particular world. Boy, this is really in the way. I hope this hasn't been a problem all. Then I can run the engine, and here, all I can do now is say, hey, give me all the vertices of this particular box, loop through them and draw them, all the vertices of this particular box. And so you can see I could start to customize the colors if I wanted to. If I run this again, one of them is now red. And then down here is the ground. I can make that white, et cetera, et cetera. So you can see, so you can sort of see what I'm doing. I'm not doing any of the physics. This is the magic of using a physics engine, which I'll come back and do some more. Okay, so let me show you some other examples. This is an example that just stacks a whole bunch of circles. One of the things that I'm doing in this example that you'll notice I'm using something called a mouse constraint. So a mouse constraint, if I added it to this list, a mouse constraint is a special kind of constraint that allows you to, a mouse constraint is a special kind of constraint where you can have an object that's attached to your mouse. So one of the things that is often awkward with physics engines is you don't want to just set to interact with something, you don't want to set the location automatically. Because that kind of violates the laws of physics. You're really saying like, I want this object to be here. You're telling it to teleport, and the physics engine is going to get confused. Well, what if there's stuff in between those two locations? So a solution is to kind of tug stuff around the screen, and that's what you're kind of seeing in this example. And I'm going to do some more proper tutorials or build some of these as coding challenges from scratch. But you can see in the code for this particular example, I'm creating this mouse constraint somewhere here, which has a stiffness, which is one of its particular parameters. So there's a lot of pieces to how all this stuff works, but that gets added to the world. So that's also, and you can see I'm adding some boundaries here and that sort of thing. So, and then the other last thing that I'll show you, which is a little example, is making a chain. So you can see there's a constraint here that's just tying the top one to this arbitrary location, and then each one of these is connected by a constraint. I'm actually not drawing the lines between the two, but you can see that I've created this sort of chain here that I can tug around and swing and that sort of thing. So, so this is what's coming next week. I'll try to carve out some time to start with this so that I can maybe take an hour or two live stream to actually do some tutorials about this. And hopefully you'll find that interesting. Okay, that's a little bit about matter.js for you as a bit bonus to the end of this stream. I'm looking in the chat to see if there's anything that anybody's saying that I should answer, but I think that's pretty good. What else did I not get to? This thing. Not going to happen right now, I guess. Okay, so thank you guys for tuning in to this kind of insane live stream. If there's a lot of noise in the hallway again, and I am happy to take one or two questions. I often get this question. I'm going to head home and have a nice weekend. Thank you, 8-Bit Engineer. Do the objects have a mass property? I think they do, actually. They certainly have a density property in matter.js. And I'll show you, there's a lot of properties and a lot of things that you can do with it that I'll come back and show you. Please make an app. Well, I don't know when I would have time to make an app. Good night, thank you, good night. So let me just say a few words here. I keep two chats. Going. There is a Slack channel for those of you who are interested in learning about the patron program of the coding train. I don't know if that's a thing, being in the patron car. Is it like being in, oh, that's terrible. It's the quiet car, really. That's my favorite car. In Amtrak trains here in the States, we have the quiet car. That's where I always try to sit. But if you're interested in supporting the work that I'm doing with this channel, you can go to thecodingtrain.com, click on the Become a Patron link. Please subscribe, like, share, all that sort of stuff. I think I'm supposed to say that. I will be back next week. I hope to be able to try to come in bonus sometime earlier in the week to cover some of this matter.js stuff. Just stay tuned to my Twitter at Schiffman. That's where I'll kind of announce that a bit last minute. And if I can schedule it in advance, I'll announce it in advance, of course. But I'll definitely be back next Friday at my usual time, 10:30 a.m. Eastern time, which kind of generally means 11 a.m. But I will try to, for once, start by 10:30. Thank you, guys. I never even played the This Dot song.
As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do
There was no like forgetting of the this dot really in the coding challenges today, but there was a lot of errors. So I hope you this is what programming is. It's painful. It's really particularly painful when you're doing it like a live broadcast. I wonder how many people are still watching now. Probably everybody just left, or left quite a while ago. And I'll play my goodbye song. which is always, I wonder if there's just an issue with that lullaby. Because now it seems to be fine. I don't hear any crackling or stuttering. Now it's working. Oh yeah, oh, okay. Anyway, I'm sorry, I'm too in love with my ridiculous soundboard. Wow, there's still 450 people watching. I'm sure most of the people just have it on in the background. The goodbye song is something on SoundCloud when I looked up Rainbow SoundCloud. SoundCloud.com. Rainbow. It was like old-timey. It was something old-timey. But then I started doing like Creative Commons or public domain, so I'll have to find it again. But it was something that I knew would work. 1:30 a.m. in the UK. By the way, I hope I might be in the UK this summer for a while. Maybe we can do a European meetup or live stream. Oh, I will be at this conference. Might as well, if anybody wants to meet and say hello. Is this the correct? The Codeland conference. I don't know which day or time I will be at. What are the dates? There's still April 21st and 22nd. Is the 21st a Friday or a Saturday? I'm not sure. Anyway, I'm planning to be at this conference. If anybody wants to say hello, people often ask me when you're going to be at an event, and we can say hello or get stickers. I will bring stickers to this. So yeah, take a look at this. 2:30 in Croatia, 2:30 in Spain, 2:32 in Europe. I'm still playing my goodbye song. Feel like showing some of my stuff at Schiffman from Robin. Did I miss it? Where do I find it? I've got a few minutes to just show one more thing. I would love to show it. I can't. You're gonna have to post the link again, or tweet it to the Coding Train Twitter. Random walkers constrained. Unprepared stream. Oh, look at this. All these people are tweeting me various things. Okay, I guess I'm gonna. I don't have that. So many people gave me all these great suggestions. CodePen. I bet you if I go here, it'll be like one of the first ones. Random walkers constrained. Let's take a look at this. Change view. Write a sentence to me to describe how this is working. So this is a project by Robin Lefebvre in the Slack chat. It's the last thing I'm going to show. And I can see that it's, whoa, I'm having some kind of like optical illusion thing going on with this. It's looking all curvy to me. So this is called Random Walkers Constrained. And if you can send me like 2 sentences or a short few sentences that describe how it works, I will read those out loud rather than just try to speculate how it works. It's a set of 2 pieces. Whoops. Hold on. It's a set of 2 pieces. I'm waiting. Picking a new tile randomly, being constrained in the highlighted tiles. Interesting. No problem. So I encourage you to, everyone interested in this, maybe, is there a way on CodePen to ask questions or to comment on it? So everybody check out this CodePen. It's a really a nice variation on the random walkers idea, constraining to a grid and showing which are able to be picked based on some highlighting. And we can see that, one is on the, I think there's a lot of possibilities of ways that you can think about different like turn-based games in this sort of way. Okay, so thank you for sharing that. I'm sorry that I'm like a little out of it, Robin. I hope I did your work somewhat justice. And I am going to leave and say goodnight now after my 2.5-hour live stream on the YouTube. And I will see you all another time. Goodbye. This, I think this, I'm going to just not have, I don't know if I can archive this. Okay, comments are not available on the full page. Okay, thank you guys. Then yes, there may be life out there in the universe. See, I can't even talk anymore. My brain is completely melted. It's been a very long day. Okay, goodbye, good night, and enjoy your week. I'll see you next week.